2025 A-Level Combined Mathematics Paper 1, Part B, question number 11, Part B. The previous part, Part A of 11, was discussed in this video in the top right here. Moving on, Part B is all about the factors of polynomial functions. The first part here says, let A be an element of the real numbers. Show that if x minus a is a factor of the polynomial p of x, then there exists a polynomial s of x such that p of x minus x minus a times p prime of x is equal to x minus a squared times s of x, where p prime of x is the derivative of p of x. So we need to prove that. And after that, the second part of the question says, let g of x be this whole thing, which is x cubed minus lambda x squared minus 2x minus x minus 2 times 3x squared plus mu x minus 2 for x element of the real numbers, which means that it works for all real numbers, which means that this is a polynomial identity. The left hand side identity is exactly equal to the right hand side. It then says that lambda and mu are some real constants. It is given that x minus 2 is a factor of g of x, and the remainder when g of x is divided by x minus 1 is negative 3. Now, provided all of this, we are expected to show that lambda is equal to 1 and mu is equal to negative 2. And finally, using 1 above, deduce that x minus 2 squared is a factor of g of x. Now note, x minus 2 squared is a factor of g of x can be proved using 1, so likely we're going to need to use this thing right here, where we do have the form of x minus a squared, where a is likely going to be 2 here, and then we need to have g of x, the right hand side, the other side equation, all of this stuff here being equal to some function p of x times minus x minus a times p prime of x, where p prime of x is the derivative of that function p of x. So to do that, let's first assume that we have a factor, as in, let's assume here, assume x minus a is a factor of the polynomial p of x. So we're assuming at the start that x minus a is a factor of p of x. So if this is the case, it means that p of x can be written as x minus a times some other polynomial. So we can see that therefore p of x must be equal to x minus a times some other polynomial, which for our purposes I'm going to be calling q of x. So times q of x, and we're going to call this equation 1, and we're of course going to have to say that q of x is some polynomial, where q of x is some polynomial. Now again, we don't know anything about this, but we know it must be true. So it's some polynomial. Now, given this, let's try to take the derivative of both sides and see what happens, because we're going to have to do that at some point in order to get p prime of x, which is there in this equation here. So let's do that. So let's take the derivative of 1. So doing so, on the left hand side we get p prime of x, which is the derivative of p of x, but on the right side we have a product of two functions. Now as we know, when you take the product of two functions and you take its derivative, it's going to be equal to the first function's derivative times the second function plus the first function times the second function's derivative. So to start off, the first function's derivative, x minus a's derivative, is going to be 1. Since x minus a's derivative is x's derivative, which is 1, minus a's derivative, which is 0. So it's going to be 1 minus 0, which is 1, multiplied by q of x. So multiplied by q of x, and then to that we're going to have to add the first function, which is x minus a, times the second function's derivative, which I'm going to just write as q prime of x. Now when we write q prime of x, we need to of course say that q prime of x is the derivative of q of x. So I'm going to call this equation number 2, and I'm going to say that where q prime of x is the derivative of q of x. Now this might be implied, like you might already have implied that this is the case, but I would rather just write it out as well, just to be 100% clear. So now we have that p prime of x is equal to q of x, which is 1 times q of x, so q of x plus x minus a times q prime of x. Now from equation 1, q of x, this thing right here, is equal to p of x divide by x minus a, because if you divide both sides by x minus a, you're going to get that q of x is equal to p of x divided by x minus a. So for that reason, what I'm going to do is to take 2, and I'm going to take 2 and multiply it by x minus a. If I do that, the left hand side becomes x minus a times p prime of x, and the right hand side becomes x minus a times q of x, and plus x minus a times x minus a, which is going to be x minus a squared times q prime of x. Now from this we're going to substitute 1. If we substitute 1, we can see that x minus a times q of x is going to be equal to p of x. Since up here x minus a times q of x is p of x. So doing so, we get that x minus a times p prime of x is equal to, this bit right here is going to be replaced by p of x plus x minus a whole thing squared times q prime of x. So now we have this, but what we want up here is the form p of x minus a times p prime of x. So in order to do that, what we're going to have to do here is to subtract all of this stuff from both sides, and as it turns out now, to isolate p of x minus a times p prime of x, we're going to have to also subtract this other part of x minus a squared times q prime of x from both sides. Doing so, we get p of x minus a times p prime of x to be equal to negative x minus a squared times q prime of x, which I'm going to write as x minus a squared times negative q prime of x. Now note, since q was some kind of polynomial, the derivative of q prime is also going to be some kind of polynomial, and negative q prime of x is also going to be some kind of polynomial. So therefore, we can say that this thing is just some kind of polynomial, and for the purpose of the question, since they call that polynomial s of x, I'm also going to do the same thing and just call this thing s of x. So you have s of x times x minus a squared on the right hand side, and on the left hand side you have p of x minus x minus a times p prime of x. Therefore, we have just proven what we needed. We have the form p of x minus a times p prime of x, where p prime of x is the derivative of p of x, and it is equal to x minus a squared times some other polynomial s of x. So we've proven the very first part. We've proven that there exists some kind of polynomial s of x, and we've actually shown exactly what s of x is. S of x is negative the derivative of q of x, where q of x is p of x divided by x minus a. So we've shown all of that and more, but we didn't really need that. We just needed to show that some polynomial times x minus a squared. So now if you look at the next part of the question, the next part of the question after that is question number 2. So we'll put this as number 1 and move on to number 2. So number 2 says, let g of x be all of this stuff here for x element of the real numbers, where lambda and mu are some element of the real numbers, and it is given that x minus 2 is a factor of g of x, and the remainder of g of x when divided by x minus 1 is going to be equal to negative 3. So using that, we're supposed to show that lambda is 1 and mu is negative 2. So for this purpose, we're going to first write this thing down and then apply the knowledge of x minus 2 being a factor and x minus 1 g of x divided by x minus 1 being equal to negative 3. So let's go down, let's rewrite g of x. G of x is equal to, and if I go up again because I forgot, g of x is equal to x cubed minus lambda x squared minus 2x minus x minus 2. So x cubed minus lambda x squared minus x minus 2 times something minus x minus 2x rather, I was incorrect, minus 2x minus x minus 2 times 3x squared plus mu x minus 2. So we have minus 2x here, not minus x. This needs to be minus 2x and x minus 2 times 3x squared plus mu x minus 2, and that is what g of x is equal to. So first off, we know that x minus 2 is a factor of g of x. So we know that since x minus 2 is a factor of g of x, if we substitute g of x equals 2, as in we substitute g of 2, then whatever factor part here, whatever this thing is multiplied by, which is some other function, we know that g of x is equal to x minus 2 times some other function which I'll call k of x or something. If we substitute x equals 2 into here, we can see that this whole bit is going to be equal to 0, so it doesn't really matter what k of x is equal to, the whole thing is going to be equal to 0. So see, we can see that since x minus 2 is a factor of g of x, g of 2 must be equal to 0. So therefore, if we compute g of 2 is going to be 2 cubed from this part right here minus lambda times x squared, which is going to be 2 squared, minus 2 times x, which is 2, minus all of this, which is going to be 2 minus 2 times a bunch of stuff which we don't really care about, is going to be 0, but we'll just write it anyway. 2 minus 2 times 3 times 2 squared plus mu times 2 minus 2, and that all is going to be equal to 0. So I'm going to actually take this to the left side a little bit, so I can write equal 0 on the very far right. So it's all going to be equal to 0. If we simplify down, the 2 cubed is going to give us 8. The minus lambda times 2 squared is going to give us minus 4 lambda. And this minus 2 times 2 is going to give us minus 4. And that all of this is going to be equal to 0. So we have plus 0, since this 2 minus 2 is going to be equal to 0. And this is all going to be equal to 0 in the end. Now if we simplify, we can see that 8 minus 4 is going to be equal to 4. We have 4 minus 4 lambda. 4 minus 4 lambda is equal to 0. 4 minus 4 lambda is equal to 0, meaning that lambda is equal to 1. So hence, we have proven that lambda is equal to 1. Now, for the next part of the question where we're going to be finding mu, we're going to need to use the second fact that we know about g of x, which is that if you consider the remainder when g of x is divided by x minus 1, it is equal to negative 3. Now what this means is that g of x is of the form x minus 1 times some other function which we will for now call h of x plus negative 3. Negative 3 is the remainder when you divide g of x by x minus 1. So from this we can see if we substitute g of 1 is going to be equal to x minus 1, which is going to be 0, times h of 1, which is going to be h of 1. We don't really care about it because it's going to be multiplied by 0, and plus negative 3. Which means that g of 1 is equal to negative 3. So we can see by the remainder theorem, which you probably want to write, by the remainder theorem, since g of x divided by x minus 1 has remainder of negative 3, we can say that g of 1 must be equal to negative 3. Now if we substitute in g of 1, we can see that what we get is 1 cubed. G of 1 is equal to 1 cubed, and then minus lambda times 1 squared, so minus 1 times 1 squared, since we know what lambda is equal to 1, so minus 1 times 1 squared, and then minus 2x, so minus 2 times 1, so minus 2 times 1, and then x minus 2, which is going to be 1 minus 2, so minus 1 minus 2 multiplied by all of this stuff, which is going to be 3x squared plus mu x minus 2, which is going to be 3 times 1 squared, 3 times 1 squared plus mu times 1 minus 2, which if we simplify, it's all going to be equal to minus 3. Simplifying down, we get 1 minus 1 minus 2, and then this minus times 1 minus 2 is going to be minus 1 times minus 1, which is going to be plus all of this stuff, which is going to be 3 plus mu minus 2, which is all going to be equal to minus 3. Now if we simplify, this minus 1 and 1 cancel, giving us just nothing here, and then minus 2 and minus 3 can be cancelled to give us minus 1 on the right hand side, so we have minus 1, and then all of this stuff is going to give us 3 minus 2, which is going to be 1 plus mu. So 1 plus mu is equal to minus 1, meaning that mu is going to be equal to minus 2. So there we go, we've solved mu as well. We've solved mu using the remainder theorem, and we solved lambda using the factor theorem. So now we have both mu and lambda. Now the next part that they're going to tell us after that is that using 1 above, deduce that x minus 2 squared is a factor of g of x. If we look at 1 above, we can see that 1 says that p of x minus a times p prime of x is equal to x minus a squared times s of x. So in this thing, x minus a squared is a factor of the overall polynomial. So if we had, instead of x minus a squared, if we had x minus 2 squared, then we would have what we're looking for, since the right side would have a factor of x minus a squared, and therefore the left side would have a factor of x minus a squared. So in order to do that, we need to show that if this is g of x, then g of x is of the form p of x minus x minus a times p prime of x, where a is equal to 2. Now if we take a look at g of x, we can see that it looks quite similar to that. If we consider g of x is one polynomial here minus x minus 2 times another polynomial here. So all we need to do in order to show that g of x has a factor of x minus 2 squared and some other function out of that is that this function that we have inside of here is the derivative of the function that we have outside of here. So let's go down and take a look and see if that is in fact the case. So we're going to go, I think we should start with a new page for this one. If we consider g of x is equal to x cubed minus lambda x squared, which is minus just 1x squared since lambda is equal to 1, minus 2x minus x minus 2 times 3x squared plus mu x, which is going to be minus 2x since mu was equal to minus 2, and then minus 2. Now, consider the format of this thing that we have here. This is x minus 2. This thing right here, if we call it p of x, let's see if this is right. This right here is the derivative of p of x. So if we take the derivative of p of x, it's going to be 3 times x squared minus 2 times x, and then this is going to become minus 2. And if we look at the thing that we have inside here, we have 3x squared minus 2x and minus 2. So we can see from that the thing that we have on the inside here is in fact p prime of x if p of x is this thing right here. So we have p prime of x in here, provided that this is p of x. So we have p of x minus x minus 2 times p prime of x, and g of x is equal to that. So we can say that since we have the above format where a is equal to 2 from question 1, we'll just say I, we can say that g of x must be equal to x minus 2 whole thing squared times some other polynomial s of x, where of course we need to say that where s of x is a polynomial. So now that we have this, we can see that therefore g of x has a factor of x minus 2 squared, since we can clearly see that g of x can be written as x minus 2 squared times some other polynomial. So therefore we have concluded that g of x has a factor of x minus 2 squared from the fact that g of x can be written of the form p of x minus some a times p prime of x, where this function here is p prime of x and x minus 2 is going to be the value of x minus a, as in, a is going to be equal to 2, and therefore we get the format of p of x minus x minus a times p prime of x that we had in question number 1. So that's going to be the entire solution for this question. Since in the previous video I gave the previous question 11 part A 85 marks, this part is only going to get 65 marks, which I think is fair. The first part is far bigger than the second part. So if you consider the marks assigned, for the first part where you take the fact that x minus a is a factor of the polynomial p of x to mean that p of x is equal to x minus a times q of x, you're going to get 5 marks. When you then take the derivative of that and you obtain that p prime of x is going to be equal to q of x plus x minus a times q prime of x, you're going to get another 5 marks. When you then use that fact and you combine these two together to finally get the final form of the first part of the question that they were asking, which is that p of x minus a times p prime of x is equal to x minus a squared times s of x, you're going to get another 15 marks. After which, when you get to this point and you start thinking about g of x, when you realize that the factor theorem is going to mean that g of 2 is equal to 0 and all of this, you're going to get 5 marks. When you then use that by substitution to find that lambda is equal to 1, you're going to get 5 marks. Similarly, for the remainder theorem, when you establish that g of 1 is going to be equal to -1, or you establish the remainder theorem like this, you're going to get 5 marks. Afterwards, when you find mu to be equal to -2, you're going to get another 5 marks. Finally, when you establish the pattern here, where you have on the front p of x and p of x's derivative inside of the brackets multiplied by x minus a, where in this case a is equal to 2, you're going to get 10 marks. Afterwards, when you finally establish the connection, resubstitute and see that g of x must be equal to x minus 2 squared times some other polynomial s of x, you're going to get another 10 marks for finding that g of x has a factor of x minus 2 squared. So that's going to be all for this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.